Welcome to the office. We want to take a look at an example of determining or classifying a quotient group based on the fundamental theorem for finitely generated abelian groups. In other words, what we want to do is we want to describe this quotient group as isomorphic to something of the form zpi to the ri direct product with a whole bunch of things up to z. I suppose that could be ZP1R1 up to PNRN, a direct product of these Z's, with a collection of integers attached as well. All right, Z mod whatever. So I want to classify it. In our example here, we have Z4, direct product with Z7, and we are taking the quotient by the subgroup that's generated by 0, 1. In this case, what we want to do is that we want to notice that this group is exactly all of the things 0, 1 to the nth power, or n times that rather, because we use addition notation here. So we could say n times 0, 1, such that n is an integer. And then we could also recognize that this is really just 0, n, where n belongs in Z7. Because I'm going to end up having this inside of Z4 direct product with Z7. So all of my entries here will turn into 0 through 6. But this is exactly equal to Z7 bar from our previous theorem, a couple theorems ago, actually. But that allows us to recognize that Z4 cross Z7 mod what's generated by 0, 1 is indeed equal to, right? Because this and that are the same thing. So it's not isomorphic to, but actually equal to in this case. Z4 direct product with Z7, quotient by Z7, Z7 bar, that is. And from our previous theorem, we recognize that this is just Z4. And that's exactly what we were looking for, right? We wanted to express it as a direct product of integers modulo something and the integers. So 0 copies of that, just one of these things. Perfect. That looks great. So that's all that we wanted to do for this example. Again, that one was a relatively simple example. We'll look at some more interesting examples in just a moment.